Okay, so welcome back to rockstar.com. We're looking at rockstarETL, and this is one of the most powerful job types available, and that is the Dynamic SQL. And this allows you to build up some SQL in a very powerful way. So let's look at that idea that we covered in our SQL job, where we used a SQL statement to clear the partition. So what we did was we used an update statement to move any data that was in the current partition to yesterday's partition. Now this is all fine and well for one table. And what we could do in our case, we have invoice lines as well. So we could have two statements. We could have invoices and invoice lines, two separate statements, and we could have it as two separate job steps. We could have one for invoices over here and another one underneath, or sharing the same step 2 spot. We could have two job steps in step 2 to execute, and we could have two different statements, two different text files, and two different files sitting in our WWI queries folder. However, this does not scale well, because say now we had 15 or 20 or 30 staging tables, it becomes a bit tedious to have to now write a separate update statement for every single table that we want to do. So fortunately, we have our Dynamic SQL to the rescue. So let's put this at the moment in step 3 of our cleanup pipeline. And I do want to be notified, so I'm going to enter my email address, project, location. I'm going to call this multiple partition operation. Alright, so dynamic column names, the pub separated list of column names from the parent SQL statement that are used in the child SQL statement. Alright, so let's see how this works. So we've got a parent statement, the location, cloud storage, bucket name and path of the parent BigQuery SQL statement, and the child SQL statement. The path to the file in cloud storage containing the child BigQuery SQL statement. Any valid standard SQL statement, including DML. Alright, so how do we do this? How do we build this up? Alright, so we want to build a dynamic statement here. So what we want to do is build a statement like this, and we'll say as TBL name and as TBL name. Alright, so this effectively becomes our parent statement, and what we're going to do is we're going to substitute our column name here. We're going to put it in over here. And then this is not going to validate anymore. But that's fine. So what effectively is going to happen here is we're creating, if I just run this, we're creating a parent statement that has TBL name as the column name with two values, invoices and invoice lines. And now this could be 20 or 30 rows long, for example. And what's going to happen is our Dynamic SQL job is going to dynamically create the SQL statements and run them. So how this works is we're going to choose TBL name as our dynamic column names, the pub separated list of column names from the parent SQL statement that are used in the child SQL statements. So in this case, we're going to just say TBL name. The parent SQL statement here will be this one. So let's save that. We'll just call it parent update partition. .SQL. And then we need to move that to our cloud storage. So this is parent update partitions. So we've got our buckets, folder, and statements. And then our child statements. So TBL name is the column name. This value, what's going to happen is this statement is going to be run as many times as there are rows in here. So what it's going to do, it's going to run for the first time, and it's going to substitute TBL name over here, and it's going to put invoices in over here. And then invoices will now validate over here, and it's going to execute that statement. And then what it's going to do, it's going to move to the second row over here and substitute what was in the original TBL name. It's going to put invoice lines in here, and that's going to validate. All right. So the key is a parent statement here. This alias, or this column name over here, we take that and we put it into our child SQL statement there. Now remember, this won't validate because we are going to dynamically build this up. So we copy that, save this, just like so. We're going to save this as child update partitions.SQL. And we're going to copy that into cloud storage. So this is child update partitions. Like so. So we've got our dynamic column name, and we could use multiple column names here for more complex statements. Just make sure they're pub separated. List of column names. So you could have really complex. So for example, you could have So you could build up a very complex arrangement here where you could have TBL name being substituted here with invoices over here, and then you could say time P, and you could have it like that for current dates. This would then run once for the first row, so time P would be substituted with current dates, and TBL name over here would be substituted with invoices, and that would be a valid statement that would be executed once. Would then go to the next row, and TBL name, which we had here, would be substituted with invoice lines, and time P, which we had here, would be substituted with date, and then this would run for the second row, and you could have multiple rows. So this is extremely powerful, this dynamic SQL, because it allows you to build up your statements dynamically, which is an advanced capability that is not possible in the BigQuery UI or in the command line interface. And then how you would represent this in the Dynamic SQL job is you would have a pipe separator. So you would have TBL name, pipe, and whatever you alias your second column as over here, time P. And then you'd have your parent and child statements. Right, so but in our case we don't have a second one, so we're just going to have TBL name, we've got our parent statement and our child statement, and in this way, let's take these out. We would be able to very easily build a update or delete statement here that could do as many tables, could do many tables, say 30 or 50 tables here. It would just iterate through each line, executing the statement while substituting in accordingly. So that's the Dynamic SQL. Let's save that. So what I'm going to do is move this to the load pipeline, save it. See, now it's gone out of the cleanup one, it's now in the load one, and same thing for this one. Move it to the load one, save it, and there it's now in the load one. Now we're only left with this one, and because it's step 3 and it's the only one, let's put it as step 1, and let's run it here. And go and check our stack driver logging. And we've got a success notice starting step 1 of our cleanup pipeline. Checking for authorization to rerun. Right, so parent statements, select invoices as TBL name, union all, select invoice lines as TBL name, step 1 of our pipeline cleanup. There's our subquery string, which has our TBL name, where we update it, set the partition where the partition is today. Dynamic column names are TBL name. Iterating through parent results 1. So this is what I was talking about, our parent statements. This would be iterating through row 1. Then it builds the query, and you'll notice that here now it doesn't say TBL name anymore, it says invoices, because it has substituted TBL name over here, which was our child statement, So as our child statement has TBL name over there, it's substituted TBL name with invoices over here. So invoices becomes stats, and this validates. And then to update invoices, set partition to yesterday, where partition is today. Finished executing the query. Then it's iterating through parent results 2, which will now be this one. So we'll take TBL name, substitute this, and put invoice lines. Final status is success. You see what's happening here in the logs. It says we've checked 0 times, we'll recheck again in 5 minutes. It's just giving it a chance to run before we recheck the status of the job. Doesn't need to go again, doesn't need to reloop. Finished step 1, completed the pipeline. All pipelines completed. You be our rock star. Now we can go and disable our job by choosing 0 number of runs per day and saving it. The Dynamic SQL job type is extremely powerful for managing your data in BigQuery and performing multiple operations on your data warehouse. It's extremely powerful, and that is how we do it with rockstarETL.